If you've been paying attention, you'll know that we left off the last video with this wood-fill PLA printed plant stand. So delicious smelling when it's printing that you want to eat it. But that doesn't help the fact that it's an absolutely garbage print. Now in this video, we're going to fix that. If you just want the information how to calibrate your printer because you have the same printer, you can skip to this time code right here. But if you haven't seen it, I highly recommend that you watch the other video, which is linked right here. It'll give you a lot of great context and maybe fill in some information that I might not provide in this much shorter video. Okay, without further delay, let's get into it. I'm doing a dry run with the printer, which means that I'm just printing without any filament, and the heated bed and heated nozzle are both turned off. And the whole point of this is just to run the stepper motors through their paces, make them do all of the work that they would do during a normal print of this plant stand. And while that's happening, I'm feeling the steppers for temperature, and they're just a little bit warmer than my body heat. So they're definitely not hot, which means that we can actually overclock them. We can feed more voltage to these steppers, which should give them more torque, more holding power, and hopefully eliminate the skipping. Before I jump into editing the configuration file, I want to give a shout out and a thank you to a few really helpful comments on the last video. Monkey Fi here pointed out that I need to check the config override file as well as the config file. Apparently the config override file can just rewrite whatever values you tried to change, so I'm going to look into that. Anthony Williams here had a good idea about unplugging the screen and then resetting just the board, so that might work without doing the nuclear reinstall and auto calibration deal. I tried unplugging the screen from the main board and then resetting the main board without this unit attached, and no, it didn't accomplish anything. So I don't know why I thought that was the source of the problem, but has nothing to do with it. There is another comment by Gerald Dax about directly accessing the files without taking the SD card in and out of the computer. So that's a good idea. Right here we can see the USB drive, and that's actually reading the printer. And there's the config file, so I can get in there and actually open it with Notepad, which is cool. So I can edit it right here and then just save it, and I don't need to do all that jazz with ejecting SD cards. Except that if I reinstall, I at least have to eject the screen SD card and put the install files back on that one because I can't directly access that SD card through the USB cable. Looking back here, we see this config override, and that's what Monkey Fi was talking about. But if I double click on this, it says do not edit this file, so we're not supposed to touch that file. So that's a dead end as well. I think when you reinstall, it doesn't let you do anything with the printer because it has to build this Delta Grid file. And unfortunately, I don't have any way of looking at this Delta Grid file because if I try to open it with Notepad, it just comes out with looking like garbage. Same with the firmware.cur, just unreadable. So I'm not going to be able to directly manipulate any of these files. It looks like I'm stuck with the nuclear option, or we can go with the suggestion made by D4Kito right here to use an M306 Z0 and then of course save your value to the EEPROM with M500. So that feels like a bit of a hack. I would prefer to do things at the base level, meaning modifying the firmware, but if this works, then I think it's the better option. Let's take a look at the Repetier G-code cheat sheet here, and we see M306 Z0. You're basically supposed to put your tool head at the 0 point and then issue this command and then save it with M500, and it'll be permanently saved and you won't have any problems. D4Kito, it looks like you win the day. So let's put this all together and see if it works. First thing I want to do is right click, cut those, and save them here in the backup folder. Now we're left with just our config file here, and we'll paste in the firmware.bin, which is the file that you get from smoothieware.org. Then what we'll do is open the config file. Now right here we are actually in the USB drive, so we're looking at the printer through the USB drive. And so let's just directly manipulate that configuration file there. First thing I want to do is scroll down to my gamma max. And I've changed that to 400. We can just change it to 500. That's pretty close. The real value, as I determined it, that I had working was 527.34 in my case. Yours will be different, but I think 500, maybe 490 is safe for everybody, but that's a good place to start. So that's not going to change. Scrolling up here towards the top, what we do want to change though is these voltages. So alpha current is currently set at 1.5. Let's change that. We're going to add about 15% more power. So 1.7, 1.7, 1.7. And I think the stepper motors will still run plenty cool with 15% increase in the voltage there. Okay, so file, save that, and we can close it down. Next thing we want to do is open up the full-size SD card. That's the blue SD card that goes into the screen. And I want to keep these two G-code files there. Those are going to be useful, but we don't need those 3 files there. Instead, let's paste in these other 3 files, which are the installation files. So we can do, hopefully, the last nuclear reboot that we're going to have to do. Although if we change those voltages, we will have to do the nuclear restart again. So eject that card, stick it into the screen right here. Eject the printer from the computer. And now that everything's powered off and we're unplugged, we can turn the machine back on and watch it reboot. So that's done, and now it's time to calibrate the Z height. First change this to 11.5200 and then calibrate. I forgot something. Whenever you first run the auto calibrate after a reinstall, it pops an error. You have to do it 2 times. Restart that. Now calibrate. Sweet. Now we will reconnect to the printer, and here in Repetier we will reconnect it as well. Then we will G28. Cap locks has to be on. G0, Z0. So now we know that we need to change the software end stops. So that's going to be M122 space S0, G0, Z negative 5. There we go. So it moves a little, and after we've done that, we can now use the buttons in Repetier host to move it. And now we can go G0 negative 23. We were at 527 before, so I just already know that that's the height that I want to be at. So just press enter. Oh, G0Z negative 23. Okay, so now we will use the buttons here in Repetier to sneak ourselves down. And it looks like we need to be at least 1 millimeter down there. That's good. So now for the fancy command, it is M306 space Z0, enter, and then M500, enter. Now we should be able to go G28. I don't know why my printer slams home so hard. I don't really like that. I'm gonna have to look into that. But anyway, let's go G0, Z0. Boom. Perfect. Awesome. I'm doing another dry run. So it's been printing for 37 minutes and 44 seconds. And these steppers aren't any warmer than they were before. So maybe just like 1 or 2 degrees. Yeah, so we can get away with even more voltage. I'm 42 minutes into it this time. And these are warm. They're warm, but they're not uncomfortably warm. So I think I'm gonna leave it at this setting, which is 2. It's a value of 2 in the config file. I can't think of a better way to test the skipping except to just do a whole new print of the plant stand. Cross your fingers, let's hope it works. As you can see, the shape of the print is perfectly the way that it's supposed to be. I changed up the design a little bit. It now has a very flat top. There's one big problem that I'm still having though, and that is the stringies. You can see them, they're pretty bad right there by my pinky finger. I don't know what's causing that. I had my retraction set at 55 millimeters per second, so it was a quick retraction, and 8 millimeters total retraction. So that really slowed my print down, and I still was left with all this. So it might have something to do with the knockoff Volcano, the E3D Volcano hot end that's on this thing. So maybe I need to put a better hot end on the printer, and that will solve that problem. If you guys have any pointers about how to get rid of this, I mean, you'd think that with that crazy retraction, you'd think that I would be able to not have all these stringies everywhere. And I had one other problem, and that is the filament. So I didn't realize, but PLA filament can actually soak up moisture from the air. I thought that was only a problem with ABS filament. See all that right in there? All those little skips? I was listening to the printer as it was printing, and there were lots of little snap, crackles, and pops. So this filament has been sitting out in the elements for months. I'm thinking of actually filling the inside of it with sand. So like drilling a hole in the top and just letting the sand cascade down inside there. We'll see. So now that I've done this perfectly, I'm actually going to do a little bit of redesigning before I print that next version in wood fill filament. So normal 3D printer problems now, almost nothing specific to this machine except that salmon skinning. Now the interesting thing about salmon skinning is that it's typically complained about in reference to Delta printers, but Cartesian printers can absolutely suffer from the same problem. Particularly, the Tevo printers all seem to have it. So the Tevo Tornado has this scalloping salmon skinning as well. And the reason that these Tevo printers seem to suffer from that is because Tevo tried to do something good, which is they tried to use the DRV8825 chip, which is an upgrade to the A4988 chip.
And what makes the 8825 better is the fact that it can do 1/32 of an inch microstepping instead of 1/16 inch microstepping, which is what the 4988 is limited to. Now I did a little digging on the internet over here at Tom's 3D forums, and is this Tom Sanlader's website? Because it's got a similar theme, that light blue color and the diamond, but I can't find anywhere that says if it's him or if it's other people doing this. But anyway, this Jamie over here on this forum made this wonderful comment right here, so informative. So I'm basing a lot of what I'm saying based on this one stranger on the internet's advice. So I don't know if it's 100% correct. But he says that the 8825s skip steps and wind with motors with low voltage and or low inductance. Well, that is the exact behavior that we're getting out of this printer. So I have not tested it, but I suspect that the stepper motors on these Tevo printers are low voltage and or low inductance. And that combination of the better 8825 chips with the crappier motors means that it's a whole system that doesn't work. So you could theoretically just upgrade your stepper motors and not upgrade your chips and still have 1/32 of an inch microstepping, which is a whole lot quieter than almost every other printer. Like every printer that I've reviewed came with the 4988 chip on it. So this is an upgrade if you do it right. Now, over here on the RepRap forum, I found this A4988 versus A8825s, but this is pretty old, I think. And he's talking about making a jumper. Look at this little jumper wire, because 24 volts and low amperage operation, that might be also what's going on with this printer. But the problem is that this chip is integrated onto the MKS SBase board. So I don't really want to go soldering on that board and risk breaking the whole board. This just seems like a bad strategy to me, especially because we now have the option of upgrading to an even better driver, and that is the Trinamic stepper sticks. Now I do have to point out also that here in my firmware, I changed my alpha current, beta current, and also gamma current to be 2. Now I don't know if that means that I'm sending 2 volts to the stepper motors or what. I don't know what this variable affects, okay? But I think it means 2 volts. So back here on the RapRap article, the usual reference voltage when you're adjusting the potentiometer is 0.8 volts. But the integrated 8825 chips on the MKS board don't have a potentiometer. So I think that means that this is where you're controlling the voltage in software. I think I'm sending 2 volts to those steppers, which is a lot. But I have printed at a setting of 2 for 20 hours now, and it works. But according to this article, anything above 0.8 volts should be burning up the 8825 chip. So maybe we can just chalk this up to really good cooling in that case, and the heat sinks are really good as well. But for whatever reason, it's working for me, and I'm not in EE. So if somebody that's watching this is better at electronics than I am, please pipe in the comments and tell me why overclocking worked, because I'm sure we would all like to know.
So it's pretty well known on the internet that you can use TL smoothers as long as you're using the 8 diode ones. The 4 diode ones don't have an effect, but the 8 diode ones seem to make the scalloping go away on the Tevo Tornado as well as the Tevo Little Monster. But there's an even better solution, and that is to use Trinamic TMC 2100s or 2108s or 2130s. And all those should, just with the chip, they should get rid of this scalloping. Now I have ordered both Trinamic chips as well as TL smoothers. So we will definitely see a solution to this scalloping here in an upcoming video. But for now, that's the worst of it that's related to this printer. Now another interesting thing about salmon skinning on Delta printers is that it faces the pillars. So this faces that vertical upright, and I'll just hold on to that one. And then 60 degrees around the corner here, we will find the next one, and that faces the other pillar, and then the third pillar is right there. So pretty cool. But yeah, still something I'd like to get rid of and increase the quality of the prints coming out of this printer. If you are especially observant, you might have noticed that I moved the fan from the inside of the control box to the outside, and that was to give myself extra space in there to install the Trinamic stepper sticks as well as the modules that allow them to plug in. So I've already begun that modification, but I have to wait a few weeks or maybe even a month for the rest of the parts to arrive in the mail. But as soon as I have those parts in hand, you can be rest assured I'll be making a video. So go ahead and subscribe and ring that bell so you don't miss it. Also, maybe donate to my Patreon. The link is in the description. Just a thought. And that's how you break your printer.